Picture this. You're standing beneath a star-strewn sky, the vastness of the cosmos stretching endlessly above you. Each twinkling light is a story, a fragment of a universe so grand, so enigmatic, that even the greatest minds in history have been humbled by its mysteries. Albert Einstein once quipped that two things might be infinite, the universe and human stupidity, and he wasn't entirely sure about the universe. That playful jab carries a profound truth. Our universe is a riddle wrapped in starlight, a tapestry of galaxies, nebulae, and black holes that both dazzles and defies our understanding. What is its shape? Does it have an edge? How did it begin, and where is it headed? These questions have echoed through centuries, and while we've uncovered breathtaking answers, the cosmos still holds secrets that keep us gazing upward in wonder. Welcome to a journey that spans the entirety of existence, from the fiery birth of the universe to its potential icy end. This is a story of discovery, of humanity's relentless quest to map the stars and unravel the forces that shape our reality. Along the way, we'll peer through the lenses of cutting-edge telescopes, marvel at the ingenuity of scientists, and confront the invisible energies that push galaxies apart. By the end, you'll see yourself not just as an observer, but as a vital piece of this cosmic puzzle. So, grab a seat, hit that like button to join the cosmic conversation, and let's dive into the greatest story ever told, the saga of our expanding universe. Don't forget to subscribe and ring the bell to stay with us for more mind-bending explorations. Let's start with a question that seems simple but is anything but. What does the universe look like? If you close your eyes and imagine it, you might picture a vast inky void dotted with swirling galaxies, glowing stars, and the occasional supernova bursting like a cosmic firework. That's not a bad start, but it's only part of the picture. Just a century ago, in the early 1920s, scientists believed the universe was far smaller, confined to a single galaxy, our Milky Way. The idea of countless galaxies scattered across an immense cosmos was unthinkable. Yet thanks to the brilliance of astronomers and the tools they wielded, that view was shattered, revealing a universe far grander than anyone dared dream. The key to this revelation lay in measuring distances across the cosmos. No small feat when you're dealing with scales so vast that a tape measure is laughably useless. Scientists turned to a method called parallax, a bit like the way your eyes work together to judge depth. As Earth orbits the Sun, completing a 300 million kilometer loop every 6 months, nearby stars appear to shift slightly against the backdrop of more distant ones. By measuring this shift and applying some basic trigonometry, astronomers can pinpoint a star's distance with stunning precision, up to about 400 light years away. Beyond that, the shift becomes too tiny to detect, like trying to spot a penny from 1,000 miles away. But the universe is far bigger than 400 light years, so scientists got creative. Enter the Hertzsprung-Russell diagram, a cosmic cheat sheet that maps stars by their color, temperature, and brightness. Main sequence stars, which make up most of the universe's stellar population, follow a predictable pattern. Their color reveals their intrinsic brightness. By comparing how bright a star appears from Earth to how bright it should be, astronomers can estimate its distance, even for stars far beyond the reach of parallax. This method, though less precise, opened the door to measuring distances across our galaxy and beyond. For galaxies themselves, the challenge was even greater. How do you measure the distance to something so far away that individual stars blur into a fuzzy glow? The answer came from a special class of stars called Cepheid variables, which pulse with a regular rhythm. In 1912, astronomer Henrietta Swan Leavitt discovered that the brighter a Cepheid variable, the slower its pulsations. This relationship became a cosmic yardstick. By timing a Cepheid's pulses, scientists could calculate its true brightness, compare it to its apparent brightness from Earth, and deduce its distance. This breakthrough, refined by Edwin Hubble in the 1920s, proved that fuzzy patches in the sky, like the Andromeda Galaxy, were not nebulae within our Milky Way, but entire galaxies millions of light years away. Suddenly, the universe was not a single island, but an archipelago of countless galactic islands. This discovery reshaped our understanding, but it was just the beginning. Hubble's observations revealed something even more startling. The universe is not static. It's alive, dynamic, and expanding. If you're intrigued by how we measure the cosmos, drop a comment below with your thoughts. Have you ever tried stargazing and wondered how far those lights really are? Let's keep the conversation going. Imagine the universe as a vast cosmic balloon, its surface studded with galaxies like glittering jewels. As the balloon inflates, every galaxy drifts farther from its neighbors, not because they're moving through space, but because the space between them is stretching. This mind-bending idea came from Edwin Hubble's work in the 1920s, when he noticed that the light from distant galaxies was redshifted, stretched to longer, redder wavelengths, a sign they were moving away from us. Almost every galaxy he studied was racing outward, and the farther away they were, the faster they receded. This wasn't random motion, it was evidence of a universe in constant expansion. This discovery was so revolutionary that even Einstein, the titan of modern physics, struggled to accept it. His theory of general relativity suggested a dynamic universe, but he clung to the idea of a static cosmos, introducing a cosmological constant to keep things stable. Hubble's findings proved him wrong, and the cosmological constant was shelved for a time. The universe, it turned out, was not a fixed stage, but a living, breathing entity, growing larger with every passing moment. But why is the universe expanding, and what does this mean for its past and future? To answer that, we need to confront a paradox that puzzled astronomers long before Hubble. Why is the night sky dark? In an infinite, static universe filled with countless stars, every line of sight should end at a star, making the sky blaze as bright as the sun. This conundrum, known as Olber's paradox, suggests that a static, eternal universe can't exist. The darkness of the night sky hints at a universe with a beginning, an end, and a dynamic nature. The Hubble constant, currently measured at about 70 kilometers per second per megaparsec as of August 21st, 2025, based on data from the Planck satellite and other observatories, quantifies this expansion. For every million parsecs, about 3.26 million light years of distance, galaxies recede 70 kilometers per second faster. This means that beyond a certain distance, roughly 14 billion light years, galaxies are moving away from us faster than light itself, forming an observable universe beyond which we cannot see. This boundary, a cosmic horizon, explains why patches of the sky remain dark. The light from those distant realms simply hasn't reached us, and some of it never will. The expansion also turns the universe into a time machine. When we look at nearby galaxies, we see them as they were millions of years ago, their light taking time to reach us. Distant galaxies, billions of light years away, appear as they were shortly after the universe's birth, chaotic star-forming maelstroms. Yet those galaxies are just as old as our own. They've simply moved farther away as space expanded. This realization led to a profound idea. If the universe is expanding now, it must have been much smaller in the past. Rewind the clock far enough, and you arrive at the moment of creation itself, the Big Bang. What's your take on the idea of an expanding universe? Share your thoughts in the comments, and let's explore this cosmic mystery together. About 13.8 billion years ago, the universe wasn't just small, it was a point of infinite density, a singularity where space, time, and matter were born. No atoms, no stars, just a searing hot soup of fundamental particles. Then, in an instant, it began to expand, cooling as it grew. Quarks combined into protons and neutrons, which formed atomic nuclei. Eventually, atoms coalesced, gravity sculpted stars, and galaxies took shape. This is the Big Bang theory, the cornerstone of modern cosmology, supported by observations like the cosmic microwave background, a faint glow of radiation from the universe's infancy, mapped with precision by satellites like Planck. But how do we know the universe is 13.8 billion years old? Scientists use the Hubble constant to trace the expansion backward, calculating when everything was squeezed into that singular point. Multiple methods, studying the cosmic microwave background, the motion of galaxies, and the oldest stars, converge on this figure with 99% accuracy. Yet there's a wrinkle. A star nicknamed Methuselah, located just 200 light years away, appears to be 14.5 billion years old, give or take 800 million years. Discovered in 2000 and studied extensively with the Hubble Space Telescope, this metal-poor star challenges our timeline. Could our measurements be off, or is Methuselah an outlier formed before the universe fully stabilized? The James Webb Space Telescope, operational since 2022, is now probing such mysteries, revealing galaxies that formed faster than expected, hinting that our models may need tweaking. The Big Bang also reveals a universe without a center. Every point expands away from every other point, like raisins in a rising loaf of bread. Whether you're on Earth or a planet billions of light years away, the universe looks the same, expanding uniformly. Gravity, however, fights this expansion, pulling galaxies into clusters and superclusters, forming a filamentary web with vast voids between. This cosmic tug of war force shapes the universe's structure, but something else is at play, something invisible, pushing galaxies apart faster than gravity can hold them. That something is dark energy, and it's rewriting the story of the cosmos. If you're fascinated by the Big Bang, hit that like button and share this video with a friend who loves cosmic mysteries. As if the universe weren't mysterious enough, scientists discovered that galaxies aren't just moving apart, they're accelerating. This revelation, confirmed in the late 1990s by observing distant supernovae, stunned the scientific community. Expansion alone requires no extra energy, but acceleration demands a force, and no one knew where it was coming from. Enter dark energy, a mysterious force that permeates all of space, driving this cosmic speed up. According to the latest data from the Planck mission and the Euclid Space Telescope, launched in 2023, dark energy accounts for roughly 68% of the universe's total energy, with ordinary matter making up just 5% and dark matter about 27%. What is dark energy? Scientists aren't sure, but they have theories. One idea revives Einstein's cosmological constant, suggesting that empty space itself holds energy that pushes against gravity. As the universe expands, more space means more dark energy, fueling further acceleration. Another theory points to quantum mechanics, proposing that virtual particles, fleeting pairs of particles that pop into existence and vanish, might exert a repulsive force. However, calculations of this energy overshoot by a staggering 120 orders of magnitude, earning it the title of the worst theoretical prediction in physics history. A third hypothesis, called quintessence, imagines dark energy as a dynamic field like gravity or electromagnetism that varies across space and time. Unlike the cosmological constant, quintessence lacks a clear explanation, leaving it as speculative as it is intriguing. Observing dark energy is like chasing a ghost. Telescopes like Bingo in Brazil, operational since 2024, study hydrogen radiation in cosmic voids to detect matter distributions influenced by dark energy. Meanwhile, the Euclid Space Telescope is mapping a third of the sky, capturing 26 million galaxies in its first data release in 2025. By analyzing how dark energy shapes these structures over 10 billion years, Euclid aims to reveal whether it's constant or evolving. These missions, combined with AI-driven data analysis, are peeling back the veil on this invisible force. Dark energy isn't just a curiosity, it's the key to understanding the universe's past and its ultimate fate. What do you think dark energy could be? Drop your wildest theories in the comments below. Every so often, the universe sends us a messenger from beyond, a cosmic traveler that carries secrets from the dawn of time. In July 2025, astronomers in Chile spotted one such visitor, an interstellar comet, a 7-billion-year-old relic half the age of the universe itself. Unlike objects born in our solar system, this comet hails from another star, ejected long ago into the vastness of space. Its composition, studied using the Atacama Large Millimeter Submillimeter Array, offers a snapshot of the conditions in a distant ancient star system, providing clues about galaxy formation when the universe was still young. These rare visitors are like time capsules, preserving the chemical fingerprints of their origins and challenging our understanding of how stars and planets coalesce. The discovery of this comet, reported widely in scientific journals and analyzed in depth by outlets like The Economist, underscores the dynamic nature of our universe. Unlike the static cosmos once envisioned, our galaxy is a bustling hub, occasionally brushed by objects that have wandered for billions of years. These interstellar interlopers remind us that the universe is interconnected, with material exchanged between stars and galaxies over cosmic timescales. By studying their trajectories and compositions, scientists can piece together the history of star formation and the distribution of elements essential for life. Imagine the stories this comet could tell. Born in a distant nursery of stars, now drifting through our solar system. What other secrets might such travelers reveal? Share your thoughts in the comments. Zoom out far enough, and the universe reveals a breathtaking architecture, a cosmic web of filaments, walls, and voids that spans billions of light years. Galaxies aren't scattered randomly. They cluster along glowing threads like dewdrops on a spider's web, separated by vast empty voids where little matter resides. This structure, mapped in unprecedented detail by the Euclid Space Telescope's 2025 data release, is the result of gravity and dark energy battling for dominance. Gravity gravity pulls matter into dense superclusters, while dark energy stretches the space between, creating voids that grow larger as the universe expands. This interplay shapes the universe's large-scale structure, turning chaos into a delicate filamentary pattern. The cosmic web is more than a pretty picture. It's a laboratory for testing our theories. By studying the distribution of galaxies, scientists can probe the effects of dark energy and dark matter, which together outweigh visible matter by a factor of 20. The Bingo telescope, for instance, examines hydrogen emissions in voids to detect subtle ripples left over from the Big Bang, known as baryon acoustic oscillations. These ripples, frozen into the universe's structure, reveal how matter clumped together in the early cosmos. As of August 2025, Bingo's early results suggest that these patterns align with predictions, but anomalies could hint at new physics. The cosmic web is a testament to the universe's complexity, a reminder that even emptiness tells a story. What do you think the universe's structure reveals about its origins? Drop your ideas below. As we ponder the universe's grand tapestry, it's easy to feel small, a fleeting speck in an infinite expanse. Yet, consider this: every atom in your body was forged in the hearts of ancient stars, born in the fiery crucibles of supernovae billions of years ago. You are not separate from the cosmos, but a product of it, a living bridge between the Big Bang and the present day. The same laws that govern black holes and galaxies shape your existence, from the gravity that keeps you grounded to the chemistry that fuels your thoughts. This connection is profound, a reminder that exploring the universe is also a journey of self-discovery, as we uncover our place in the cosmic narrative. Humanity's quest to understand the universe is a saga of ingenuity and wonder. From Galileo's first telescope to the James Webb Space Telescope's infrared gaze, we've built tools to peer deeper into space and time, each discovery a testament to our curiosity. The 2025 data from Euclid, capturing millions of galaxies, and the upcoming Nancy Grace Roman Space Telescope, set to launch in 2027, are pushing the boundaries further, revealing a universe that defies our expectations. These efforts aren't just about facts, they're about asking the big questions. Why does the universe exist? What is our purpose within it? Every step forward brings us closer to answers, and you're part of that journey. Share your thoughts on humanity's role in exploring the cosmos in the comments. Beneath the grandeur of galaxies and the vastness of the cosmic web lies a realm so strange it challenges our very perception of reality, the quantum world. At the smallest scales, where particles flicker in and out of existence, the universe operates by rules that defy intuition. Quantum mechanics, the science of this domain, has revolutionized our understanding of the cosmos, offering clues to mysteries like dark energy and the Big Bang itself. For instance, the idea that virtual particles, ephemeral pairs that pop into being and vanish, might drive the universe's acceleration, suggests a connection between the subatomic and the cosmic. Yet, as we learned, these calculations overshoot by 120 orders of magnitude, a humbling reminder of how much we still have to learn. The quantum frontier is where the universe's deepest secrets hide, waiting for us to unlock them with ever more precise experiments and theories. Recent advances as of August 2025 are bringing us closer to these answers. The Large Hadron Collider at CERN, upgraded in 2023, continues to probe the Higgs field, which gives particles mass and may hold clues to dark energy's nature. If the Higgs field can tunnel to a lower energy state, as some models suggest, it could alter the fundamental laws of physics, reshaping the universe as we know it. Meanwhile, quantum experiments in laboratories worldwide are testing theories like string theory, which posits extra dimensions and new fields that could explain dark energy's repulsive force. These efforts, though speculative, highlight humanity's audacity to probe the universe's foundations, from the smallest particles to the largest structures. What quantum mystery fascinates you most? Drop your thoughts in the comments, and let's dive into the weirdness together. In our quest to unravel the universe, we're no longer relying solely on human ingenuity. Artificial intelligence is transforming how we explore the cosmos. As of August 2025, AI tools are sifting through the deluge of data from telescopes like Euclid and James Webb, identifying patterns in galaxy distributions, classifying celestial objects, and even predicting the behavior of dark energy. For example, Euclid's first data release, covering 26 million galaxies, was analyzed using machine learning algorithms that can and process vast datasets far faster than any human could. These AI systems don't just crunch numbers, they uncover subtle correlations that might escape even the sharpest minds, guiding astronomers toward new hypotheses about the universe's structure and evolution. AI's impact goes beyond data analysis. It's helping design the next generation of telescopes, optimizing their sensitivity to detect faint signals from the early universe. Projects like the Square Kilometer Array, set to begin operations in 2028, will rely on AI to manage its unprecedented data flow, potentially revealing new insights into the cosmic microwave background or the distribution of dark matter. This fusion of technology and curiosity is accelerating our understanding, turning raw data into stories of cosmic birth and growth. It's a reminder that our tools, like our minds, are extensions of our desire to know more. How do you think AI will shape the future of astronomy? Share your predictions in the comments. Beyond the equations and telescopes, the universe invites us to grapple with questions that are as philosophical as they are scientific. Why does the universe exist at all? Is there a purpose to its expansion, its galaxies, its fleeting moments of life like ours? These questions, sparked by discoveries from the Big Bang to dark energy, push us to confront our place in a cosmos that is both magnificent and indifferent. The universe doesn't need us to exist, yet here we are, pondering its mysteries, weaving stories from starlight. This act of exploration, whether through a telescope or a moment of reflection under the stars, is what makes us human, a species driven to find meaning in the vast unknown. The search for cosmic answers often mirrors our search for personal ones. The universe's expansion, driven by dark energy, reminds us of life's impermanence, urging us to cherish the moment we have. Yet the possibility of a cyclic universe, reborn through a Big Bounce or Penrose's conformal cycles, offers a kind of cosmic hope, an eternal renewal that echoes our own aspirations for growth and transformation. As we await new data from missions like the Nancy Grace Roman Space Telescope, set for 2027, we're reminded that every discovery is a step toward understanding not just the universe, but ourselves. What philosophical questions does the cosmos spark for you? Share them in the comments, and let's ponder the meaning of it all together. Now, let's turn our gaze to the future. The universe, born in a blaze of creation, is hurtling toward an unknown destiny, and dark energy holds the reins. Will the universe expand forever, growing cold and desolate? Will it collapse in a fiery crunch? Or could it cycle through endless rebirths? The answer hinges on the nature of dark energy, and scientists have mapped out several possible endings, each more dramatic than the last. Let's explore these cosmic finales, from the chilling Big Freeze to the explosive Big Rip, and consider what they mean for everything that exists. The Big Freeze, a cold, lonely end. The leading theory posits that dark energy is the energy of the vacuum itself, constant and unchanging. In this scenario, the universe expands forever, accelerating until galaxies are flung beyond an event horizon, like ships sailing past the edge of a cosmic map. Over billions of years, the Milky Way and its neighbors, bound by gravity, will remain intact, but distant galaxies will vanish, their light red-shifted into oblivion. Stars will burn out, planets will freeze, and black holes will evaporate through Hawking radiation, leaving a universe in thermal equilibrium, a state of maximum entropy where nothing happens. This is the Big Freeze, or heat death, projected to unfold over 10 to the power of 106 years, a timescale so vast it dwarfs the current age of the universe. Yet, there's a glimmer of hope. Physicist Roger Penrose's conformal cyclic cosmology suggests that this desolate, radiation-filled state might resemble the conditions of the Big Bang, potentially triggering a new cycle of creation. While evidence is scarce, the idea that our universe could be one of many in an eternal cycle is a tantalizing possibility. Imagine a universe that dies only to be reborn. What a story that would be! The Big Rip, a cosmic shredding. If dark energy comes from exotic fields that gain energy over time, so-called phantom dark energy, the universe faces a more violent fate. As this energy grows, it overpowers all other forces, even within galaxies. Space expands so rapidly that it reaches infinite volume in finite time, perhaps just a few billion years from now. The cosmic event horizon shrinks, isolating galaxies, then stars, then planets, and finally atoms as dark energy tears everything apart. This is the Big Rip, a singularity where the universe becomes infinitely large and hot, ripping matter into its fundamental pieces. The latest models, updated in 2025, suggest this scenario is less likely, as dark energy appears to behave more stably, but the possibility remains a chilling reminder of the universe's power. The Big Crunch and Big Bounce. Collapse and rebirth. If dark energy weakens over time or stems from a field with negative potential energy, the universe could stop expanding and collapse in a big crunch. Gravity would pull galaxies together, compressing space until the universe resembles its primordial state, hot, dense, and chaotic. Current observations, including Euclid's 2025 data, suggest our universe is flat or open, making a big crunch less likely, but it's not impossible. Alternatively, if the collapse is rapid, the universe might not fully crunch, but instead bounce into a new phase of expansion, a scenario called the Big Bounce. This cyclic model, distinct from Penrose's, envisions the universe oscillating through phases of expansion and contraction, each Big Bang a rebirth from the ashes of the last. The shape of things to come. These scenarios, Big Freeze, Big Rip, Big Crunch, or Big Bounce, depend on dark energy's behavior and the universe's geometry. The Euclid mission and upcoming telescopes like the Nancy Grace Roman Space Telescope, set to launch in 2027, are gathering data to narrow these possibilities. For now, the Big Freeze seems the most probable, but the universe loves to surprise us. Each ending challenges our imagination, reminding us that we're part of a story far larger than ourselves. Which fate do you think awaits the universe? Share your thoughts in the comments, and let's speculate on the cosmic finale together. As we conclude this cosmic journey, take a moment to reflect. You are a part of this vast unfolding story. The same forces that birthed stars and sculpted galaxies flow through you. The universe, with its mysteries and marvels, is not just out there. It's within you, in every atom forged in the hearts of ancient stars. From the Big Bang's fiery dawn to the potential chill of a big freeze, the universe is a testament to the power of curiosity and discovery. Tools like the James Webb Space Telescope, which in 2025 revealed galaxies forming faster than predicted, and Euclid mapping millions of galaxies, are pushing the boundaries of what we believe is possible. But this story isn't over. Every new observation, every breakthrough brings us closer to understanding our cosmic home. So keep looking up, keep asking questions, and keep exploring. Hit that like button if this journey blew your mind, share this video with someone who loves the stars, and subscribe to join us for more adventures in the cosmos. Comment below with your thoughts. What's the biggest mystery you want science to solve?